In this problem, we want to find the area between our curve and the y-axis. Our curve is f of x is e to the 2x minus 4. We want to go from 0 to natural log of 4 over 2. That does seem like a very random limit, but we'll go with it. Okay. So the first thing you always want to do is graph it, because most importantly you want to know, is this curve above or below, oh, I wrote the y-axis, I meant to say the x-axis. We're always finding the area between the curves and the x-axis. Okay. So we want to know if it's above or below the x-axis. So it looks like we're going from 0 to natural log of 4 over 2. Now, just for my own knowledge, I put this in my calculator, and that's about 0.69, just so I kind of know. So I want the area between my curve from 0 to about 0.69. Now that actually looks like it might be really close to where my curve intersects the x-axis. I do need to know for sure, because I need to know if maybe I need to find a little bit where the curve is above the x-axis. So let's actually go through and figure out where my y-intercept is, or my x. So to find your x-intercept, you take your equation and set it equal to 0. So e to the 2x minus 4 equals 0. So e to the 2x equals 4, and to get rid of that e, you take the natural log of both sides. So if you take the natural log of both sides, we get 2x equals natural log of 4, and x equals natural log of 4 over 2. So it turns out that's why they picked such a random upper limit, because that is our x-intercept. So basically we want the area from 0, which is a very logical place to start for many real-world applications, to where my curve crosses the x-axis. But most importantly, I now know that my curve is below the x-axis for the area that I care about. And if you want to find an area when it's below the x-axis, you do the area equals the integral of negative f of x dx. And the reason why is because we're saying, okay, the curve on top is 0, so you do 0 minus the function on bottom. Okay, so in our case, my area is going to be equal to 0, that's my top function, minus the actual function, which is e to the 2x minus 4 dx. So that's why, because 0 doesn't matter, that's why they always say this is negative f of x. So we want to take this integral. This will be the integral. Oh, sorry, we want to go from 0 to natural log of 4 over 2. Okay. So from 0 to natural log of 4 over 2 of negative e to the 2x plus 4 dx. So to integrate, that negative will still be there. E to the 2x, the e stays the same, but you divide by the power in front of, or the number in front of the x, plus, and that 4 integrates to 4x. And we want to evaluate from x equals 0 to natural log of 4 over 2. And I hear this is the part where it gets complicated, just trying to simplify with that really weird number. So we plug in the top one first, so this will be negative e to the 2 times natural log of 4 over 2, all over 2, plus 4 times the natural log of 4 over 2, minus negative e to the 2 times 0 over 2, plus 4 times 0. Now this 2 over 2 cancels, so we have negative e to the natural log of 4 over 2, plus this 4 and that 2 will simplify to 2 natural log of 4, minus e to the power of 0 is just going to be 1, so this is going to be negative, so minus a negative 1/2 minus 0. Okay. Now e raised to the power of natural log, those cancel, so we get negative 4 over 2 plus 2 natural log of 4 plus 1/2. So we have negative 4 over 2 plus 1/2 is negative 3/2 plus 2 times the natural log of 4. And we should be able to stop there.